So this starts 4-6, which is called inverse functions. If a function is a rule for turning x values into y values, then the inverse is going to turn y values back into x's. So think of you have a machine, and inside your machine you put, say, social security number, and out comes the person's name. Then the inverse is you plug in someone's name and then it spits out the social security number. So let's look then at a quick example, and then we'll kind of draw some comparisons with this. All right, so I have actually a bunch of parts on this because I'm going to kind of wrap a lot of concept stuff into one example to illustrate a lot of things. So find the inverse relation of this relation, 1, 4, 2, 3, negative 1, 4. Then I want to give the domain and range of both S and its inverse. Then we're going to graph both of them. Are they both functions y or y not? Okay, so let's start. So for A, give the inverse relation. So S says that 1 maps to 4, 2 maps to 3, and negative 1 maps to 4. So that's the rule. So for my inverse relation, literally all I'm going to do is I'm going to swap x and y, because, so inverse of S. Because if S turns 1s into 4, then the inverse needs to turn 4 back into 1. This point is 2, 3, so S turns 2s into 3s, so my inverse needs to turn 3 back into 2. And then this point, when I swap, I get 4, negative 1. The inverse is just going to tell me how to get an output, or what input I need to get a specific output. So S says if you want a 4, plug in a 1. My inverse says, oh, a 4 came out of your machine, you must have plugged in 1. All right, so there's the inverse of S. So B is give the domain and range of each. I'm going to set this graph here because I want to use that for my graph, and I want to make sure I leave room for it. So give the domain and range of each. Remember that the domain is the x values and the range is the y values. So if you have a graph, you can just pick it off by looking at the picture. You can just list the x values, and if you have like a function expression, which we're going to do in a second, then you can use, those 2 steps that I've talked about with you guys. So S, what are x values for my S relation? 1, 2, and negative 1. All right. The range is the stuff that comes out. So what comes out is 4, 3, and 4. And you don't have to list the 4 twice. You can just list it once. All right, so for the inverse of S, so the domain is the x's, so 4, 3, 4. I can just list 4 and 3. And the range is the y's, so 1, 2, negative 1. Okay, so what this points out is that the domain of your original function is the range of your inverse, and the range of your original function is the domain of the inverse, which makes sense, right? I'm going to draw a picture in a second, but if your function maps from domain to range, then your inverse must map from range back into domain. All right, the next question asks us to graph both relations. Are they functions y or y not? So I'm going to end up taping this into the notes, but for now I'm just going to move it up. Plus I want to be able to manipulate it. So I'm going to do S first. So 1, 4, 2, 3, and negative 1, 4. So there's my S. And then for our inverse, let's see, we have 4, 1. So 1, 2, 3, 4, 1. 3, 2. And 4, negative 1. All right. Now, I haven't talked about notation quite yet, but we're going to talk about it here in a second. All right, so blue is my S and red is my S inverse. Now, if I were to imagine that I can fold the plane, which because I have a physical object, I actually can. Fold the plane along the diagonal. So that represents, here's me folding. Okay. So if I were to do that, I can see that the points are going to land on top of each other, right? Folding along this line. Okay. What is this line? This would be a line with an intercept at 0, 0 with a slope of 1. So this is the line y equals x. So a relation and its inverse are symmetric about this line. And that's going to come up again later, but you know that if you graph a function and its relation, it's going to have symmetry about this. Okay, so there's our graph. I'll be able to tape that right there. C also asks, are they both functions, y or y not? So for functions, you can either, with this one it's pretty easy, you can just like draw the arrows between them. But if you have a graph, which we happen to, you can also do the vertical line test. So because I've got a grid, it makes it pretty easy. For my blue, S does pass my vertical line test, right? So no vertical line intersects more than once. However, my inverse function, here's 2 points that lie on a vertical line, so it's not a function. So S is a function, but the inverse is not, because of the points 4, 1 and 4, negative 1. So those are the problem, right? All right. So what this example does is it introduces us to a lot of the information that and properties that we have about inverses. Inverses interchange x and y. The graphs are symmetric about y equals x because we're just changing x and y. The domain of your original function is the range of your inverse. The range of your original is the domain of the inverse. And just because you start with a function, does not mean that the inverse is automatically a function.